In this video, I'm going to go over the vector review problem to remind you of how to add vectors, something that we're going to need in this class. So the first step that I did in class already is let's visualize what these vectors look like and let's give them names. So let's call this vector A, vector B, and vector C. So the first one is 315 degrees, which we said was over here. This right here is 315 degrees. So that means that both of these small angles here are 45 degrees. So this is vector A. And then vector B is 180. So 180 is like this. So vector B is along the negative x-axis here. And then we have vector C, which is 60 degrees. So it's going to be this way. And this is 60 degrees here. I have not drawn these to scale. I just wanted to visualize where these vectors were. The reason I wanted to do this, even though you could use these angles directly when you solve this problem, is because a lot of times in this class you're going to have pictures of the vectors and you're not going to have angles such as 315 degrees. You'll have angles shown like this here where you may have vector A and you're given this angle 45 degrees. So the first step when you're adding vectors is to separate the x and the y directions. So I like to draw a line on my paper. And I'm just a very visual person, so I like to show that I'm separating the two directions. So this is going to be the x direction, this is going to be the y direction. I have three vectors, each of them have an x and a y component. So my first step is to write down, okay, what is the x component of each vector and what is the y component of each vector. And I always start by writing all of this. If I have three vectors, I write down the 6 components and then I figure out what the values are to plug in. So for vector A here, and I'm just going to use the angles that I drew. I'm not going to worry about these angles anymore because I've already represented these vectors here on this drawing. So the x component of vector A, if I redraw vector A here, the x component would be this one. This would be AX, and this would be AY. Right, how do you get from here to here? You go to the right and then you go down. So the x component is adjacent to this angle here. It's touching the angle, so that always uses cosine. So AX will be A cosine. A is 2 cosine of 60. The x component of B, well, B is all in the x direction. It's along the negative x-axis. So to the left is negative, and the magnitude is 5. And then, oops, this was supposed to be 45, not 60. And then vector C, the x component, if we draw this over here on the side, Cx would be the horizontal one, Cy would be the vertical one. This would be vector C. This is our 60 degrees right here. And so the x component here is adjacent to that angle. That uses cosine as well. Always think to yourself, is this component adjacent or opposite? Because the x component is not always going to use cosine. only uses cosine if that component is adjacent to the given angle. And then we're going to look at the y component. So over here, that y component is opposite, that uses sine. It's also going down, so it's negative 2 sine of 45. The y component of b is 0 because b is all in the x direction. It doesn't have any part of it going up or down. And the y component of c is over here. It's opposite the angle. It's positive because it's going up. So 2 sine of 60. And you can go ahead and plug these into your calculator and get some actual values. But once you do that, the next step is to add all of these components. So add all of the x components, and that will give you the x components of the resultant vector r. When I added these three in my calculator, I ended up with negative 2.586. And I never round until the final answer, so here I have to round because I'm writing this down on the screen. But I always use my previous answers to avoid any rounding errors. I add all the y components, and that gives me the y component of the resultant vector, which gave me 0.318. So what this means is that I've added these three vectors, and I can show this geometrically, that if I have a vector here, I start with vector A, and then I add vector B, and this is not to scale, but then I add vector C, then the resultant vector is from where I started, which is right here, to where I ended. So this vector right here would be the resultant vector. And what I found here by separating the x and the y components is I found the x and the y components of this resultant vector. So what that means is if I draw this resultant vector to the side, then what I just found is Rx and Ry. Because you can add the x components separately from the y components. You can treat the two independently. So now that I have the x and the y components of vector r, the last step is to find r. And to do that, we can see in this picture here that we have a right triangle. So we're going to use a Pythagorean theorem, which is going to tell us that r will be equal to the square root of rx squared plus ry squared. Once I plug that into my calculator, I got 2.61, and here I have rounded to 3 sig figs. And the last thing is the resultant also has a direction. Now, with this rough sketch here, and even with this rough sketch, we know which way r is going. Rx was negative, so this shows that Rx is negative. Ry is positive, it's going up. So with a negative Rx and a positive Ry, r must be going this way. So the way I like to figure out the angle is say, okay, well, let me figure out what is this angle theta. I always like to find the angle that is touching either the positive or the negative x-axis. And if I'm finding this angle that's touching the x-axis, then I can always use the inverse tan of the y component over the x component. And this will always give me the angle that is adjacent to the x component and opposite the y component. So when I did this, and I don't even worry about putting positives or negatives into the calculator, I just put in 0.318 divided by 2.586, and that gave me 7 degrees, basically 7.01 degrees. So that's the direction of this angle right here. Now in class, I said that the answer was 173 degrees. That's simply because the 7 degrees is not the standard way to define angles. A lot of times, especially in WebAssign, it's going to say what's the angle with respect to the positive x-axis. So it's going to be asking for this angle here, from here to here, which is 180 minus 7, which gives us 173 degrees.